here we are. Okay, so yesterday, do you remember us taking two logarithms and putting them together?
Yes.
So today, we are going to do exactly the opposite of that. So, we are on page 27, problem number 2, and your job is to expand this. So what that means is, instead of having one logarithm with 2 letters, you're going to have 2 logarithms. Each one will have one of the letters. Okay, so we're expanding it. This is not distributive. We are breaking this thing apart into 2 separate logarithms. Now, what you have to decide is, what do you put in between these? What do you think goes in between those?
Plus.
A plus. Why is that a plus? Because this is a times. Remember yesterday, we put these 2 together, and we put them together as a multiply? You're doing exactly the same backwards today. So, next one is log x over y. So it's going to have a log x, and it's going to have a log y, and now you got to figure out what goes between them. Minus. Why is it a minus? Because it's a divide. When you pull apart a divide, it becomes a subtract. When you put together a subtract, it becomes a divide. This works both ways. Uh-oh, here we go. Log x cubed over y to the 4th. Speaking of which, I want to thank all of you that participated in the canned food drive. I walked Dr. Bridges down there this morning. We had mountains of food and thousands of dollars. It's beautiful. But what was so cool was, you know, the different agencies come in and start picking up the cans. And so Little Sisters of the Poor had come with a van, and this little nun, little tiny sweet nun, she, hello?
Hi, sorry, Mr. Frigi wanted us to drop these off. They're for the
Thank you. Yeah. So, anyway, this little sweet little nun, very tiny, and she said, I'm okay, what shall we take? And Mr. Frigi said, well, you're the first one, so you can take whatever you want. Her eyes got real big, and she said, you mean we can have whatever we need? And he said, yes. It was just so sweet. I mean, that's what you guys are doing when you bring that food in. I know for some of you, it's all about the extra credit, but you're really, really helping a lot of people. So thank you. Yes, thank you. All right, now, this is a division problem, right? So when it comes apart, it's going to come apart as a subtraction. Now notice, I've got these powers on here, but the first step is to break it apart into its individual logarithms. Each letter is going to get a logarithm. So we're going to have the log of x cubed, we're going to have the log of y to the 4th. Why did I put a minus between here? Because that's a division. Now, there's one more step. Who remembers where these exponents go? They go out in the front. So 3 log x minus 4 log y. That is the expansion. So we started with this, one simple logarithm, and we broke it apart into these 2. Jacob?
1/5 log xy.
Okay, let's take a step at a time. He said, you know what? A radical does not coexist well with logarithms, so I'm going to rewrite this as xy to the 1/5. Okay, so you got to think about your exponents backwards now. Remember, when we had something like x to the 1/5, we wrote that as a radical and it was a fifth root. So we're going backwards now. The fifth root is the 1/5 power. And then where does the power end up going?
In front.
In front. So 1/5 log xy is what Jacob said so far, and he is 100% right, but we aren't done. Because we need to expand it, we need to pull it apart. So this is gonna be 1/5 log x plus log y. Every letter has to get its own logarithm when you're taking it apart. So I have a log of x and a log of y. And why did I choose to add them? Because that is a times. Okay? Now, if you want to, you don't have to do this at all. But could we make this 1/5 log x plus 1/5 log y? Yeah, if you want to. It's not necessary, but it's certainly okay. If you want to. All right. All right.
Log x minus
I heard 1/4 log x. Oh my gosh, that's exactly right. And you did, I mean, there's like other steps in there, but you don't need to write any of the other steps down. This is going to be a subtraction problem. And the fourth root of x is the same as x to the 1/4. And the 1/4 comes out in front. So that is exactly the right answer. Now, why is it that over here, the 1/5 went with both logarithms, but here, the 1/4 only goes with the x? Yeah, because doesn't the fourth root only go with the x in this problem? So the 1/4 has to be just with the x. Nice work, folks, nice work. All right, how about this one? Any ideas on that one, Jacob?
1/5 parentheses log x minus log y.
All right, what do the rest of you think? First of all, is a subtraction the right idea? A fifth root is a 1/5 power, so the 1/5 comes out in front. Is he right to have parentheses like that, or should it be written like this? The parentheses are necessary because the whole thing is under the radical. Now, you guys think you're pretty smart. Let's look at the next one. Any ideas about this one?
Do we change the 100 to 10 to the second?
Oh my gosh! Yes, I wouldn't do that first, Abby, but that's exactly what you do. So, look guys, isn't this a multiplication right here? So can I separate this as the log of 100 plus the log of x squared? Can I do that? Because it's a multiplication problem. Now, what happens to this 2 right here? No, it doesn't go away. It goes in front. So this is going to be 2 log x. And a lot of kids, a lot of people we'll stop here. But Abby said, wait a minute, the base is 10. Isn't this the log base 10 of 10 squared? Right here? So what's that? No. Well, actually, you could pull this 2 out in front, but what's the log base 10 of 10? 1. So these cancel, and the answer is just 2. 2 times 1, or just 2. We learned that a couple days ago. So that's 2 plus 2 log x. That is the final answer. Nicely done. Nicely done. All right, last one in this section, then we're gonna go to our calculators again. Last one in this section, here we go. What are you gonna do with this? ln 30e to the third?
Oh, yes.
Retreat to log E from Panzer.
Okay. So what?
We change it to ln.
Oh, absolutely, you can change it to log E if you wish. You can always do that. That's what ln means, right? Log base E. Now, take a clue from the last one. Isn't this a multiply right here?
Oh, yeah.
So I'm gonna pull it apart as the log base E of 30 plus the log base E of E cubed. This is a property. What happens when these two match?
Oh, it's just 3.
That's just 3. And this is ln 30 or log base E of 30. ln is log base E. And that's it. You got it? Good job. Okay. Yesterday, do you remember we typed things into our calculator yesterday, like log 5.62 or stuff like that? And the buttons that we were using on our calculator to do those problems were LOG and LN. Those were the 2 logarithm buttons that you have on your calculator. So sometimes we're confronted, as we are in the very next problem, with a different base than we have on our calculator. Your calculator does not have a base 3 button. It has a base 10 button and it has a base E button. So when we have some other base, we need to convert this to either base 10 or base E. As it turns out, it's amazingly simple. There is something called the change of base formula. And it works like this. See how you kind of have, I don't know, when you look at that problem, it's like this number is a little bit above this number. So I'm gonna make a fraction, and I'm gonna do the log of 4 over the log of 3. So this number here goes in the bottom. The one that's below goes in the bottom. Log 4 divided by log 3. And I'm just gonna type that in on my calculator, and believe it or not, that's gonna be the answer to this question. So if you have a base that you don't know, can't do, you take the log of this number divided by the log of this number. Now, I have a caution for you. When you hit log, a parentheses automatically comes up. So after 4, you have to close that parentheses. Log 4 divided by log 3. You should have gotten 1.26, how am I rounding? 10,000, 1.2619? Did you get that?
Yep.
1.2619, perfect. So anytime you have, if your problem is base 10, you just type it in. But if it's base 3, you have to change it by taking the log of that over the log of that. Now, just for fun, would you do ln4 over ln3 and tell me what happens? You have to close the parentheses on this one too. So ln4 divided by ln. Oh my gosh, it's exactly the same thing. So if you need to type it in on your calculator, you either make it an LOG or you make it an LN, it doesn't matter. But it's gotta be this number over this number. All right, try B, log base 7 of 11. What are we going to type into our calculator?
Log base 11.
Just log 11 divided by log 7. Yep, that's what we're typing in. Make sure you close those parentheses because it will not work otherwise. Log 11 divided by log 7. Did you get 1.2323?
Awesome sauces. Bits.
All right, let's take our coats off, get in uniform, and go ahead and finish these other problems. Would you go ahead and do C, D, E, and F? C, D, E, and F?
Yeah, it is. It's log Ed Johnson.
All right, what'd you get for C? Negative 2 point, okay. Negative 2.7119. I was taking attendance, so I didn't type it in. Is that good with everybody?
Yes.
And how about D?
3263.
What?
3263.
0.3263? Xavier, did you type these in? How come you're just writing them down? Have you been typing these in? Xavier, when the coach is like running drills, you just sit over the side and watch everybody else, or do you participate? Same in math class. All right, what did we get for E? 1.7959. And F?
6.4919.
6.4919. Everybody okay with that? So changing from one base to the other is incredibly easy. You just have to remember it's the log of the top number over the log of the bottom number every time. And then round it off however it's supposed to be rounded off. All right, now we got a couple problems in our book. We're gonna get through these quickly. So 54, problem 54, you do not need to worry about the problem. I'm just gonna give you an equation. That's an I, a capital I. And it's negative 0.00235. T. Oh, no, it's not. It's negative 0.0125. There we go. Now I got it right. I was looking at the wrong one. Negative 0.0125. go ahead and change that T to an X so that it looks more normal to us. So this is our equation, all right? And what this equation does is it tells us the intensity of light at a depth of X feet in Lake Superior. So this is the intensity of the light, and this is the depth of the water. So all the question says is, what is the intensity at a depth of 10? What is the intensity at a depth of 10? So remember, this is the intensity, and this is the depth. So if they tell me the depth is 10, won't I put 10 right there? Okay, I'll rewrite it. All right, and then I'm gonna go ahead and multiply that together. Actually, since it's 10, I can do that. So it's negative 0.125. Is everybody okay with that? This is where yesterday's lesson now comes in handy. We have to solve this equation. So I know the base on this is 10, right? Because there's no base written here. So I'm going to loop-de-loop. 10 to this power equals this. Remember that from yesterday? 10 to the negative 0.125 equals I over 12. 10 to the negative 0.125 equals I to the 12. I over 12, I over 12. Now, can we figure out this on our calculator? Yeah, I think so. Just type 10 raised, you know where where my finger is, that's how you raise, to the negative 0.125. Did you get like 0.7498?
Yeah.
Okay. How do we get I though? That's this number right here, but I need to solve for I, so what will I need to do? Not divide by 12.
Oh, subtract.
When I times by 12? Do I multiply by 12? So times 12, and the answer to the problem is 8.9987.
Question?
Type this in on your calculator and times it by 12. I think that's what I did. Yeah.
No, why would it be multiplied by 12?
Because you're getting rid of the
If you say
denominator.
I over 12 equals 0.8 whatever, to solve for
Oh,
I,
that's-
we
okay,
times
okay.
by 12. All right, let me give you one more little equation. And we'll be done. Well, we don't need to do this last one, it's the same thing, so you don't need to do it. We're gonna be done with 3.5, or 3.4, I mean 3.4. So that homework will be due, on Tuesday? So 3.4 is gonna be due on Tuesday.
Oh, let's go. Come on.
Try not